Hello students, so in my previous lecture I told you certain guidelines for disconnecting a target molecule. So some of the guidelines were, first of all, we should search for a functional group in a target molecule. And if there are more than one functional group, then the most reactive functional group that should be disconnected, that should be taken for the disconnection. Then we can search for CX bond in a target molecule, and that CX bond that can be disconnected. CX bond, it may be CN bond, it may be CO bond, CS bond. Okay, and then if after disconnection you are getting positive charge on benzene ring, then that is unstable one, and that disconnection is not favorable. Next one, if after disconnection the starting material that you are getting is less reactive than the target material, then target molecule, then that disconnection is not favorable, and in that case we need the functional group interconversion, that is FGI. So these were the certain guidelines. Now let's see some more strategy to disconnect a target molecule. Now if I take alcohol molecule, suppose I take alcohol, okay, and if you have alcohol, then how you will disconnect it? Here for disconnection we can do the carbon-carbon disconnection here. Okay, we will not disconnect this bond because you will not get any good starting material. Only after disconnection this you can get the H2 molecule. Okay, now so if I can do the disconnection either from here or here, so it depends whether the synthon that is formed is a stable one or not. So suppose if you are disconnecting it from here, then you may give the polarity here. This is minus, this is plus, oxygen bears minus charge, this carbon plus, and this one minus. You can give the polarity. So what should be the synthon? It is R minus plus positive charge over here. So the synthetic equivalent that you can write, that may be, okay, so this we can add a mgx over here, and for this the synthetic equivalent that would be, I have already told you in my previous lecture of synthon and synthetic equivalent. For this the synthetic equivalent that will be this carbonyl, this keto group can be added for this. Okay, and using these two reactant molecule you can get this target molecule. Okay, now suppose I take one more example. Now in this case again we can do the carbon-carbon disconnection. We can disconnect it from here, from here, from here. So from where this target molecule should be disconnected, so this is disconnected from here. So what is the reason for this? This gives a epoxide as a synthon, epoxide as a synthetic equivalent, which is very reactive one, and reaction can be done easily in presence of epoxide. So this is not a natural type of disconnection. So this disconnection, it gives some unnatural synthon, and that are called as the unplumb. So suppose I disconnect it. So after disconnection, the synthon that we are getting is, this is your synthon, and corresponding to this synthon corresponding to this synthon, the synthetic equivalent that you will write is this is the synthetic equivalent. Now all of you know this, using this synthetic equivalent reactant molecule, you can get this target molecule easily. First, this being a nucleophile, it will attack over here, this bond will break, and after hydrolysis you will get this target molecule. Okay, so if you will see, then in this case, if you see the polarity, then this bears a positive charge, this bears a negative charge, this will bear a positive charge, and positive charge over this oxygen atom is not possible, as this is the electronegative atom. Electronegative atom bears a more electronegative atom should bear a negative charge, and less electronegative atom may bear a positive charge. But here, in this case, the more electronegative atom is bearing a positive charge. So that's why this is not a natural type of disconnection, and it is giving you the unnatural synthon, and this is called as the unplong. And I will take another lecture after this, what are these unplongs. Okay, so this is unplong, and so this is, you can remember it as an exception for if you are getting such type of target molecule, then we should disconnect in this way. Now suppose, so this is only one functional group is present over here in a target molecule, and suppose if we have carbonyl compound, and only suppose one carbonyl compound is present in a target molecule, then suppose this is a target molecule, and if you want to disconnect, then we can disconnect it from here, and you will get a synthon, as this should be a positive charge, natural polarity, and this may be this CH3 minus, and corresponding to this you can write a synthetic equivalent. Cl minus can be added over here, and CH3 Mg Cl. Okay, now suppose if you take another carbonyl compound. Now if this is a carbonyl compound, then that should be disconnected from here, and you will get a synthon minus charge over here, and CH3 plus. So for this, the synthetic one. So if this is your such type of target molecule is there, then the disconnection should be in this way, and you will get. So how you can get the negative charge here? Easily, if active methylene compound is present here, if active methylene compound is there, then the negative charge can easily be generated over here. So in presence of base, this will give a negative charge at this carbon. Okay, so that's why I have added here, and this ester group is added over here. So this gives the active methylene compound, and for this you can write CH3, you can write either Br. So using this two reactant molecule, you can get this target molecule. Okay, and finally this ester group, it can be removed from here after hydrolysis and heating, it can be removed. Now suppose another one, okay. Now if you see, and here all this is a carbon-carbon disconnection, because carbon-carbon is disconnected, carbon-carbon bond is disconnected. So such type of target molecule, we can disconnect it from here, okay, and you will get a positive charge over here and CH3 minus. Okay. And for this, what should be the synthetic equivalent? The synthetic equivalent, that is, it will take a double bond, and for this you can write So this acts as a Michael acceptor, this, and here 1,4 conjugate addition will occur here. Okay, so in presence of these two you can get this target molecule easily. So this is some carbonyl compound in which one carbonyl functional group is present. Now suppose, let's see some target molecule where two functional group is present. So what should be the strategy for that? Suppose I take a beta hydroxy carbonyl compound. So here two functional group are present. So if you have a beta hydroxy carbonyl compound, then what type of disconnection we should do? We should do the 2,3 disconnection. For this, always the 2,3 disconnection is done. For this, 2,3 disconnection should be done. 2,3 disconnection means 1, 2, 3. So this bond that can be easily broken down. Okay. So 2,3 carbon-carbon disconnection, and what you will get? So if you see the polarity, then this is minus, plus, minus. So minus here, and this will be plus. Okay. So you will write the synthon minus charge, and here this is plus charge. Corresponding to this, the synthetic equivalent that you will write, the synthetic equivalent, you may add over a active, you may get an active methylene compound. You can add this ester group here, and because in presence of this active methylene compound, it can give you the minus charge over here on this carbon in presence of some base. So for this, this would be the synthetic equivalent. Now suppose if we have a alpha beta unsaturated carbonyl compound, okay. So for this, suppose if you have alpha beta unsaturated carbonyl compound, then how can we disconnect it? So we can do, for this alpha beta unsaturated carbonyl compound, we should do the FGI first. So it can be converted into this form. So if we have a it can be converted into beta hydroxy carbonyl compound by FGI. Okay, suppose if we have H over here, then it can easily be removed. So by this dehydration in presence of H2SO4, that can give you this. Okay, and further, the further disconnection can be followed like this. Further disconnection as above, the further disconnection can be done. The carbon-carbon 2,3 disconnection. So 2,3 disconnection, this is 2, this is 3, carbon-carbon disconnection can be done. So otherwise you can skip this step. You can skip this step, and you can directly disconnect this one, and you can write these two as a synthetic equivalent. Okay, so either go by this, or you can do directly this one. Now suppose if you have if you have a 1,3 dicarbonyl compound, then 1, 2, 3 we can disconnect it from here. and the synthetic equivalent that you are getting. So these here all natural. These are giving the disconnection is giving you the natural synthon here. So this is minus, this would be plus, this can be written as minus, this can be written as the plus here. Okay, so you will write the synthon minus charge over here and plus charge over here. So corresponding to this, you can write the synthetic equivalent. So synthetic equivalent, you can write active methylene, you can generate active methylene compound over here, and you can write the Cl. So what should be the synthetic equivalent? Okay, and here you can write acyl chloride or acyl bromide, you can write. In the same way, if you have, suppose if you have a I am jumping it. So if you have 1,5 dicarbonyl compound, so this is 1, 2, 3, 4, 5. Then again we can do the 2,3 disconnection. Similar to here, you can do the 2,3 disconnection. Suppose this is minus charge, this will have plus charge, and you can have the synthetic equivalent similar to this. Now suppose if you have a 1,4 disconnection. Suppose if you have a 1,4 dicarbonyl compound. If you have a 1,4 dicarbonyl compound, so this is 1,5 dicarbonyl compound, and this is your 1,3 dicarbonyl compound, and so for this 1,3 and 1,5, the disconnection, similar disconnection, 2,3 disconnection. So in beta hydroxy carbonyl compound, in alpha beta unsaturated carbonyl compound, and 1,3, 1,5 dicarbonyl compound, and if you see 1,4 dicarbonyl compound, in all these target molecule, you will do 2,3 disconnection. 1, 2, 3, this is 4. This is 1,4 dicarbonyl compound. So you will do the 2,3 disconnection. So carbon-carbon disconnection, and here what you will write, the positive charge. Okay. So in this case, if you see the polarity, so in all these cases that I discussed before this, so they, after disconnection, you will get a natural synthon, and that is containing a natural polarity. But here, if you will see, in case of 1,4 dicarbonyl compound, then here if you see, this is minus charge, this is plus charge, this is minus, whereas this is plus, this is minus, and this is plus. So this oxygen here, it is having the positive charge, so that's why this is a unplong or unnatural synthon. So for such 1,4 dicarbonyl compound, no doubt 2,3 disconnection, but we will get the unplong, and corresponding to this, the synthetic equivalent that you will get, convert it into active methylene compound, and this will be the synthon. Okay, so this is also exception here where you are getting the unplong. So in next lecture we will see more about the unplong, where you will see that this 1,2 difunctional compound and 1,4 difunctional compound, they give unplong. So these were certain strategies for the different functional group. So what I discussed the strategy, the disconnection strategy for the compound containing OH group, carbonyl group, okay, some of the compounds in which same carbon atom contains the two functional group, and then the certain carbonyl compounds. Okay, so let's take some example now from the example for the disconnection. So suppose this is the target molecule. If this is the target molecule, then from where that this should be disconnected. So I have given the example for the compound containing OH functional group. So what I told you, either we can disconnect it from here or from here. So in this case, if you see the polarity, then this is minus, this is plus, and this will have a minus charge, this will also have a minus charge. So from where we should disconnect? So from where we can disconnect, we should disconnect it from here, because in this case you will get the benzyl carbon ion. So benzyl carbon ion, that is more stable carbon ion in compared to this propyl carbon ion. So this should be the disconnection should be done from here. Now if this is the carbon, if you see, then what should be the disconnection? What type of disconnection? So if you see, then this is 1, 2, 3. So it is beta hydroxy carbonyl compound. So already I have given you the example of beta hydroxy carbonyl compound, in which disconnection should be done from here. The disconnection should be done from here, and you can write the synthetic equivalent. So we will see more examples, such type of example further. Now in this case, if you will see, then from where we can do the disconnection. So disconnection, that you will see disconnection, suppose this is the one of the ester group is present and this is the compound. Then if you see, then this is 1, 2, 3, 4, 5. This is 1,5 difunctional compound, and for 1,5 difunctional compound, I told you the disconnection should be from here. So this disconnection, so here we will have the minus charge, it will have the plus charge. Again, this will be minus, this will be plus, this will be minus. This should be the plus charge, this should be the minus charge. So 2, 3 disconnection should be done, and this 2, 3 disconnection it will produce the minus charge, and one species synthon is this negative charge synthon, and another is this. So after that, if you have a plus charge on this and minus charge on this, then what should be the synthetic equivalent? The synthetic equivalent, the H plus can be added over here, and you will get the malonic ester. And for this, the synthetic equivalent, the double, as the positive charge is present over third carbon from this carbonyl carbon, that's why you will take a double bond. So we will see such example further. We will see the disconnection and complete electrosynthetic analysis of such example further. Okay. So this, after getting these two, and this can further be disconnected. So we will see in next lecture, this can further be disconnected here, and we will get a simpler starting material. So first of all, the disconnection should be done from here, and then this can be done from here. So two disconnection will be done here. Now if you see this one, this example, then how the disconnection can be done? So in this case, as I told you, if this NH2 is present, then we should do the FGI first. So we should do the FGI first, and that can be converted into, after FGI that can be converted into this CN. So this on hydrolysis, this on reduction, it will give this target molecule. And further, for this you can write the synthon. So for this, the synthon, as I told you, and this will give you the synthetic equivalent, this one plus HC. Okay. So in this way, so these are certain examples, and we will see later on in one group disconnection, two group disconnection, we will see some more similar examples. Okay, thank you.